currently doing my MSc Chemistry from the NIT Warangal. So today we will see the spontaneous process. So what is spontaneous process? These are the reactions which start by themselves only. So there is spontaneous process. To check the spontaneity of the reaction, we first take the enthalpy. So it was said that when the enthalpy is negative, means when the reaction is exothermic, that reactions are the spontaneous reactions. But there are many, this for example, let's take one example, like CO2 combined with O2 will give the CO2. So in this, delta H is negative. So there are many reactions which is not exothermic, still they're spontaneous reactions. Like for example, the example is melting of ice. In this, ice is taking heat from the outside and they start melting. So this reaction is basically exothermic, but still this reaction is spontaneous because when we keep the ice outside, not in the cool environment, so they start melting by themselves only, and it is taking heat from the outside and they start melting. So that is exothermic reaction, but it is still the spontaneous reactions. So then this theory is not 100% true. To check the reaction, to check whether reaction is spontaneous or non-spontaneous, then we take entropy. So what is entropy? So entropy is basically tells us about the randomness in the system. So when the entropy is positive, means when the randomness is increasing, means the reaction has become spontaneous. But there are certain reactions in which the spontaneity, where the entropy is decreasing, like which is negative, means the randomness is decreasing, but that reaction is spontaneous also. So then this theory is not 100% true. This is also not 100% true. So then we take gives free energy. So this is a theory which tells us about the spontaneity of the reactions. 100% true. This theory is 100% true to check the spontaneity of the reactions. So it is given by where H is representing enthalpy, T is temperature, and S is entropy, and G is Gibbs free energy. So let's see something about the G. G is basically a state function. State function means what? It is basically depends only on the initial and the final state, not on the path which it is taking. And the second is it is intrinsic property. So extensive property. So as we know, this is a state function. So if we are taking the any cyclic process in which the initial and the final is same, so then in the cyclic process, G is basically 0. Okay, so now let's focus on this. So it's like single G do not have any significance. So then we are taking the delta G. It's like this, delta S. Now this is our, okay. So then we have this reactions. Now when G value is negative, then it is considered as a spontaneous reactions. When G is positive, then it is non-spontaneous reactions, and when G is 0, it is equilibrium reactions. Okay, so if we want, let's run this. So we have equation G is equals to delta H upon T delta S. Okay, so if we want the spontaneous reaction, so G value should be negative. So there are some conditions in which these reactions are, whether the reaction is spontaneous and non-spontaneous. So let's discuss some cases. So first we take the case number 1. If we want the spontaneous reaction, then G should be negative. So for that we have when delta H is negative and when delta S is positive, then this reaction is 100% spontaneous reaction. And when, sorry, yeah, this is positive or more than 0, or more than 0, 0 means when our delta H value is positive and this is negative, then this reaction become non-spontaneous. And there are some certain cases which we have to discuss is third case. So see, the third case is that so if you want G should be negative, so if G is negative, then it is a spontaneous reactions. So there are certain cases in which whether G can be negative. Okay, so if this is negative and if this is also negative, then this is definitely, this is not definitely, but this can be a spontaneous and non-spontaneous. It basically depend upon the temperature at which we are working. So for that we want G value should be less than 0. So we can write this like this. So we can shift T is equals to here, then this should be like this, and H is here. So at this temperature, if we are talking about the third case, so when the T value is more than this value, then this reaction can be spontaneous. Okay, so we have to find out this temperature, and if when we put the values and we can get the G value negative, then this reaction can be spontaneous. And when this is like, this value is not, this value is less, then we'll consider that reaction as a non-spontaneous reaction. Let's take one example. So here is one question. Let's do one question. So like reaction A is given, A plus 2B. So H is given as, delta H is given as 30 kilojoule per mole. Okay, and S is given as 60 joule mole Kelvin. Okay, so in this question they were asking that find the temperature at which this reaction is spontaneous. Okay, so as we know, when the temperature is more than this much, then at this temperature the reaction will be spontaneous. So then we put the values, 30 into 10 to the power 3, what is given in kilojoule, and S is given in joule only, so we can write this. And so now this is going to be 1, 2, this is going to 500 Kelvin. So when the temperature is 500 Kelvin And this condition are given like when delta H is equals to 30 kilojoule per mole and S value is 16. When we give this temperature, then this reaction will become spontaneous. Thank you.